Sorry, I forgot to record. So in this time, we're going to talk about alkaline earth metals, which is actually the group number 2 in the periodic table. It is composed of those elements: beryllium, magnesium, calcium, strontium, barium, radium. Just like in the alkali metals, they do not occur naturally as free elements, because just like the alkali metal, they are reactive. Okay, so if they are found in nature, they're going to find the compounds formed after that reaction took place, and they mostly occur as, the reactions that form those compounds are going to be compounds of carbonates, phosphates, silicates, and sulfates. And each of them is going to show a different color. Because as I was telling you yesterday, chemistry is the science of colors. Color is an evidence that a chemical reaction took place. I don't know if you have read something. I don't think so, but I'm going to say it. Wait, my beautiful voice. Wait. So there are some colors that are used. Of course, the color could be fabric, ink color, for example. But there are some colors that are used in the food industry. Colors are evidence, I repeat, of chemical reactions, and there are some colors that might be a little bit toxic. So there's a list that you can find on the internet of toxic that are mild toxic and you would like to skip. For example, when you buy groceries at a store, well, I'm not the kind of person that is going to be reading all the ingredients, okay? But there are some colors that you need to be aware of, okay? That eating a certain amount of that food, for example, after a long time eating it, it might cause a disease that is related to eating that color or that slightly amount of other elements that might be toxic for your body. So yeah, colors are beautiful, but sometimes they're toxic. They're related to poison too. Okay, so it is good that you guys be aware of that, because sometimes we buy food pre-made food that you don't know what is it made of. So it is important that we are aware of that. They occur naturally as compounds that are either insoluble or only slightly soluble in water. In other words, those compounds, if you try to dissolve them in water, they are going to be just partially dissolved, not entirely dissolved in water. The reason is because of the type of compounds that they are made of. Okay, carbonates, phosphates, silicates, sulfates, all of them have a different rate of solubility. Solubility is a characteristic and the ability that a compound has to be dissolved in water. So each of them has a different solubility rate, okay, and that is going to depend on the type of reaction that occur. Now, important characteristic number 4 consists of atoms that contain 2 electrons in the outermost energy level. We did this in the last week of the first partial. Okay, when you use the Christmas tree and you build electron configuration, you will notice that they have in the outermost shell, in the outermost level, they have only 2 electrons. And here you notice, okay, Here you notice the electron configuration. Their electron configuration has 2 electrons in the outermost level. All of them end in S2, 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 which means that in the S orbital, you're going to find only 2 electrons. In the outermost level, you will find only 2 electrons. That's what the first characteristic means. Then we are here, okay. Consists of atoms that tend to lose 2 electrons per atom, forming ions with 2 plus charge. No, así no era. Wait. Así era. Okay, the charge that they are going to have, if you see in your periodic table, for example, you look to magnesium, and if I ask you, what is the valence electron of magnesium? What is the valence electron of magnesium? What do you notice? What number is that? Guys, what number is that? In your periodic table, look for magnesium and tell me the valence electron that it has. In chemistry, we're going to have 2 kinds of compounds. We're going to have ionic compounds. There are compounds that are made up of metals combined with nonmetals. But we are also going to have molecular compounds. That is, when 2 nonmetals combine. That is a very important topic, but I'm just giving you what ionic compound means. Every time you see the word ionic, remember, ionic means that is a combination, okay? That is a combination that involves metals, okay? So every time metal is involved, you're going to have an ionic compound. They are going to react with water to form bases in hydrogen gas. So, when, for example, I combine calcium with water, the reaction is going to release hydrogen. They're good heat and electrical conductors. Why? Because they are metals. Remember, a characteristic of a metal is that they are good conductors of electricity, but also of heat. They are ductile and malleable. That means that they can be bent and they can be shattered into pieces, okay? And they have a silver luster. That means that a physical characteristic of them is that they have luster, okay? And they include the naturally radioactive element radium, okay? In that case of radium, they are radioactive. Radioactivity is one characteristic of certain elements. This element radium was, I don't know if you have watched the movie of Madame Curie.